Guys, can you hear me? Please let me know in the chat box. Am I audible? Okay, fine. Okay, guys. Yesterday I was discussed about also 2 pointers, right? Some of the very important things about 2 pointers. These are very basics and very important. We are going to be use this in different parts. 2 pointers. Okay, yesterday I have given some assignment problems. I hope you have done that one. Okay, guys. There I have yesterday I was explained one problem, that is segregation of zeros, ones and twos. That is very important, guys. That is like medium level question. That is okay. Okay, guys. Today I'm going to talk about the wiggle sort. Wiggle sort. What does it mean by wiggle sort, guys? That means, let's suppose there is an array. The index is 0, index 1, index 2, index 3, and index 4. Let's suppose these values supposed to be in this order. Array of 0, less than array of 1, greater than array of 2, and again less than array of 3, and so on, like that. That means the first value will be minimum, and next value will be maximum, and again value will be minimum. Let's check, this is 1, 0, 1, 2. And again after next value will be the maximum. Maximum means is the like higher than the beside one. Okay. After the fourth value will be lesser, like that, guys. These are the medium level question, guys. These are a medium level question. So how we are usually they have given one array and we have to convert, and we have to do the perform an operation to convert like this. Wiggle sort, we have to, it's called as a wiggle sort. We have to convert that array in this way. Like 0 means like how we are going to be find, guys? I percentage 2 equal to 0. That index supposed to be less than beside index. That means I plus 1. Right, guys? You can check, guys, here. This is the 0th index. How we are going to be check? I percentage 2 equal to 0. That means that is a even index. Guys, you can clearly see this. All even index is up here. You can see clearly. That means even index value is small, right? Odd index value is higher. Right, guys? Even index value is smaller and odd index value is more. And one thing you have to do the compare here. I percentage 2 equal to 1 equal to 1. That means odd. You can see odd values, odd index values, and compare the next index value, always be greater than the next index value. You can see this value is greater than the next index value. This value is greater than the this value is greater than the next index value. Right, guys? That means odd index value should greater than even index. Next even index. You can see next even index. Here also next odd index. So let's suppose they have given one array like this. 1, 2, 2, 3. So that means we have to convert this array to in this way. Let's suppose, wait guys. Here 1. We have to convert this array to 1, 2, 1, 2. That means even index, starting even index will be low. The next odd index value is higher. This is the next one, right? Is higher. And next one will be lower than the this odd index. That's why 1. And next index will be higher. That's why this is 2. Guys, understand this one? These are the indexes, guys. We have to convert this array to, we have to output supposed to be this one. This is we called as a Bigel sort. Guys, actually these Bigel sorts are 2 types, and lead code who are practicing, they might know about this. Okay, guys. How we are going to be implement this one? Guys, this is also part of the 2 pointers, but here I am going to take only one for loop. Why, guys? Because these are the elements, the first element and next elements are adjacent to each other. That's why I'm not taking the while loop here. See, guys, I'm taking the for loop. Int I equal to 0, I less than array dot length I plus plus. This is the base for loop. And here we have to check that element supposed to be in this order. We have to convert this order. If that is not in that order, what we have to do? We have to swap the elements. Let's suppose array is like this. 2 and 1. What we have to do? We have to swap these elements is like this. 1, 2. So first we are going to be check the relation between these two. This is the first even index. Next adjacent index. We are going to be check the relation. How we are going to be check the relation? First we have to go check whether that index is even or not. So we have checked here even, and what we have checked it? We have to check the relation between that particular index and the next index. How we are going to be checked? Actually here indexes means we have to take the values, guys. Here normally indexes only, but we have to compare the values of the indexes. If let's suppose this supposed to be array, here you can see this is our actual value. This is the final output supposed to be like this. Here array of I supposed to be less than array of I plus 1, right? But actually our input array, it's not like that. It is the reverse. How it is reverse? Array of I here greater than array of j. So that's why when the criteria didn't matches, here criteria supposed to be like this, right? But this criteria is not matched. So that's why we are going to be check that one. How we are going to be check? Array of I greater than array of I plus 1. Right, guys? If suppose this is the true, what we have to do? We have to swap the elements. What we are going to be do? Swap elements. Array of I to array of j. We are going to swap I plus 1. Sorry, I plus 1. We are going to be swap these two. Guys, understand this one? Okay. What are the other case? We have checked for the here. We have checked for the even index. Now we have to check for the odd index. How we are going to be checked? If I percentile 2 equal to 1, that means odd index, and Guys, here check this, guys. Let's suppose this is 0, this is 1, this is 2. Supposed to be output supposed to be like this, guys. Here 3, this is 1. But actually, if suppose the input is like this, means odd index value is less than next even index. That means it is not follow the criteria. So this is the actual criteria, guys. Odd index value supposed to be greater than to the next even index. So that's why we are checking whether input array is following that criteria or not. So that's why we have taken here I percentile 2 equal to 1. That means we are getting the odd index and we are going to be check the condition is following or not. How we are going to be check? Array of I less than array of I plus 1. Right, guys? In this case, what we have to do? We have to swap the elements. Array of I, array of j. Guys, understand, guys, here? Sorry, I plus 1, this one, I plus 1. Guys, understand? Please let me know. Okay, guys. Guys, here you have to understand one thing. We are using I plus 1. I plus 1 every time. So if I plus means what supposed to be here the condition, guys? In for loop, I less than array dot length minus 1. Why minus 1? If you take only array dot length, that means if suppose this is the array 0, 1, 0, 1, 2. When it's array, when the index comes to, it will go for the I plus 1. So that means go for the index of I, index of 3. But actually that index is not available. So we will get the compile time error, array out of error. So that's why we have to take here as I less than array dot length minus 1. Guys, understand this one? Okay, guys. Guys, actually we have a two wiggle sorts. Okay, short one and short two. The problems will be, this is the first one. I'm now explaining this one, guys. Sort two. The relation supposed to be like this. Number of 0, I mean that array of 0th index supposed to be less than number of first index. And same way, number of second index supposed to be less than the number of 1. That means we have to follow like this. Low to high, high to low, low to high, and high to low. Yes, this is the problem I'm explain now, and this is will be the your assignment problem, guys. This is will be your assignment problem, guys. Guys, there is nothing same logic only, but you have to apply. You should know this thing, guys. What is the relation between two numbers? You supposed to know. Let's suppose maybe equal, maybe greater, maybe less than. If you know this one, you can solve this problem. You can solve this problem. Here, less than or equal to, before problem, only less than. Output supposed to be the first problem will be like this. Low, high, low, high, low and high. But what is the output of this program? will be maybe possibility low. This one always be low and high, and maybe possibility like this same high and again low, and maybe possibility of low, maybe possibility of high, and continue like that. Here that's why they have given here less than or equal to. You can see guys, greater than or equal to. This is the very simple guys. If you know these three conditions, you can solve that problem. This is your assignment guys. You have to do this one. This is the medium level question guys. Very important. I'm going to share the link as well. Okay. Guys, these are the very important thing. Yesterday I have given some problems, right? Assignment problems, move to zeros to left. I hope you have all done that one. Okay guys. Let's implement the binary search here. Guys, before I want to tell you one thing. If you want to search an element in an array, given array, let's suppose I have given one array. Let's suppose that is 4, 7, 9, 3, 8, 10, 1. Let's suppose I have given one array. This is not a sorted. This is not sorted array. So I want to find one element. Let's suppose I want to find the element of 1. I want to search this element. I want to find means that's called a search, right? Search an element. What is the possibilities of to search this element? How many methods we have? As of now, we have only linear search. Guys, what is mean by linear search? Linear search means you have to check, you have to start from 0th index and you have to increment every index by 1. So that is we called as a linear search. Or otherwise, if you start with the length minus 1, every time you are going to be decrement that value and comes to up to 0. This is up to array dot length. This is we called as a linear search. How we are going to be implement that linear search? Let's suppose this is the for int I equal to 0, I less than array dot length, I plus plus. Guys, this is the normal array traversal, right? It is this one is we are going to be used for the array traversal. Here, when I value changes, every time I value gives the exact in I value is always be index. Using that index, we are going to be get the value, right, guys? Now we are going to be check that index, that value array of I value equal to our target or not. Actually, we need target value. So we are going to be check like that. If find, we are going to be print like found the element. Found the element. Guys, once we found the element, is it required to again iterate the loop? No need. Once we found, then we have to come out of the loop. So that's why we have taken a break here. Once the out of the for loop, that means what is the possibilities, guys? If you find the element, fine. Otherwise, we just print as a not found. We have to take one here Boolean value initially. Guys, these are very important things. Like Boolean found equal to false. Once we found the element, we have go write as a found as equal to true. Here we are going to, after the for loop, we are going to be just check whether the Boolean value has been changed to true or not. If not changed, if still found only, I mean found means false only, that means not, we didn't find the element. Guys, this is the linear search. I hope everybody knows. Right, guys? Please let me know if you guys didn't know. I will explain again this one. Okay, fine. Okay, now we are going to be implement the linear search. Sorry, binary search. Guys, what is mean by binary search, guys? When array is sorted, let's suppose array is sorted. Suppose 1, 2, 3, 4, 10. Array is sorted. Is it necessary to use linear search? What is the time complexity of the linear search? Even though we found the element while doing the linear search, what is the time complexity of the linear search, guys? O of n. Guys, you know why O of n? Linear search O of n. Why? Because it is runs based on the array length. If array length increases now, so it is also time also increases. That's why this linear search time complexity is O of n. Okay. So when they have given one property called sorted array. Guys, these are the here keyword, guys. Keyword sorted. So when you see the property sorted, so what is the need of go for the linear search? Because linear search usually take O of n time complexity. So when we find this one as a sorted array, we have to check for whether there is any better optimal solution. If you use the binary search, how much time it will take? O log n. Right, guys? I've already explained you why it will take O log of n. I will explain you today now as well. No need to worry. Okay, let's implement this one. Guys, you know, we are here using the 2 pointers. We are using the 2 pointers here. He has given one array. So I will start with the start index. I will take start index as a 0 and end index as array length minus 1. Guys, these are the free things. Start equal to 0, end index equal to array length dot minus. So I am going to check whether the start index are less than or equal to end index. Why, guys, we have to check? Because we have to traverse from here to here only. Once they met, then no need to do traverse again. Okay, guys. Here we have to find the mid element. Guys, why we need to find the mid element? Any idea, guys? Guys, just tell me. I have given one sorted array here. Sorted array, let's suppose 2, 5, 7, 10, 9, 10. Guys, I want to find the element of 9. So this is already sorted. So that's why if I go check with the middle index, if I know the middle index, we'll compare with the middle index with my target. Let's suppose the target is greater than the middle index. Do I need to search left side of this one? Left side of middle one? No need. Why, guys? Because this array is already sorted. If the middle element is already less than the target element, then no use to check the element left side of this array. Right, guys? That means, what does it mean? Array should supposed to be right side of the mid value. Right, guys? Initially, start value will be 0th position. End value will be last position. Then we are going to be check the mid value. Once we get the mid, we are going to be check with the target value. My target is here 9. So if the mid index value is greater than this one, so no need of check for the less than elements. So that's why I have to take start to this one mid plus 1. I will take as a start as mid plus 1. Guys, understand this one? Okay, guys. I will give you the another example. Let's suppose 2, 5, 7, 9, 10. Guys, I want to find the element of 4. This is my target now. Start is here, end is here. Right, guys? We find the middle element. Middle element we find the. We are going to be check middle element with the target value. Middle index value with the target value. Guys, what will happen, guys? This middle index value is greater than the target value. Then what is the use of check the other elements, right side of these elements? No need. Why? Because this array is already sorted array. Already sorted array. And the middle element is already greater than the target element. So that's why the n supposed to be mid minus 1. Because the elements will be between this range only. Guys, understand this one? I hope you clear. Please let me know. If you didn't understand, I will explain again. Because this is very important. We are going to be use this linear search in number of problems. In lead code, almost like all the medium level questions, most of the questions will be linked with this one only. If the question is tricky, they have given a one sorted array. That means you have to use only binary search. Guys, I hope you understand, guys. You have understand this concept. How binary search will work. Guys, please let me know in the chat box. Okay, fine. So we are going to be implement that one. So initially we found the once comes inside the loop, we find the middle element. How we are going to be check? Start plus n by 2. Or otherwise also we can check, that is not necessary now. Now what we have now after find the yes we can do, that is also, that is not necessary now. Okay, guys. Now we are going to what after find the element, what we are doing here, the next step we have to check the mid element with the target value, right, guys? So how we are going to be check? If mid element, array of mid element equal to target. Guys, what does that mean? If target, that means this is the index, mid is the index, right? System dot out dot println, we are right now the found. Guys, after that, do we need to continue the iteration once we found? No need. So that's why I have given a break. Guys, I have already told you there is a two numbers. What are the relationships? A equal to B, A greater than B, A less than B. Now we have taken A equal to B. Then what should we do? A greater than B. Let's check. Else, if array of mid is greater than target, that means mid value is greater than the target. I mean mid index of value is greater than the target value. That means the end value supposed to be mid minus 1. Guys, understand? Here you can check, guys. Here we have taken the mid value is 7, but our target is let's suppose 5. That means here mid value is greater than the target. Then value supposed to be before this one only, before mid only, right? So that's why the end value we are taking as a mid minus 1. Guys, I hope you understand this one. Okay, guys. What are the other condition? We have taken A equal to B, A greater than B, and now only remaining condition is A less than B. Else, what will happen, guys, in this case? If this is false, that means target value is more, right, guys? Or if you confuse it, you can take like this, no issues. In this case, target is more then the array of mid. Guys, understand? If what we have to in this case, when the target is more than the mid of the element, let's suppose here my target is 9, but mid value is only 7. So that means the element actually my required target is always be right side. So start value will be mid plus 1. Guys, understand this one? Mid plus 1. So that's why I have taken start equal to mid plus 1. Guys, understand this one? Please let me know if you didn't understand this one. I hope you clear on this. Guys, please let me know. Fine. Okay, guys. Let's implement this one. Guys, this is the actual implementation. You have to try it by your own. This is the actual logic, guys. You have to try by your own. Guys, what is the time complexity of this one? Time complexity. Guys, initially, I will tell you how to do that. Initially array size, let's suppose array size is 10. 10 elements is there. Now we find the mid element. Based on the mid element, we are going to be whether n equal to mid minus 1. That means anyway we are going to be exactly making half. Right, guys? That means initially 10. Now 5 elements. After 5 elements, what we are doing? We are doing like 2 elements. Right, guys? Next 1. Right, guys? So you can see here every time number of subarrays may be increasing. Let's suppose here one subarray. Initially totally one array. After here maybe 2 arrays, maybe 4 arrays, maybe here 8 arrays. But what about actual values, guys? What is the size of the subarrays? Every time is it decreasing. Right, guys? Every time it is decreasing. Initially length n. After first division, first mid, what will happen? That n by 2 power 1. What will happen after that? N by 2 square. What will happen after? N cube, like that, and so on. What will happen, guys? At one time, after several steps, it's going to be that element is going to be only one. Let's suppose after k steps, it is going to be only one. The subarray value, what are the values in the final subarray will be 1. Understand, guys? So now what? Now n equal to 2 per k. Guys, what is this k value? K is actual how many times subarray dividing. Understand, guys? So that subarray dividing means, what does that mean? How many times it is running? Guys, understand? That running means time complexity. Here if you find the element of value of the k, that means we found the time complexity. Guys, understand, guys? No, when there is a one equation like this, n equal to 2 power k, how we are going to be find the element of k? Simple thing, we have to apply the log for the both sides. Log of 2 power k. Guys, understand, guys? Here, let's say base 2. Okay, guys. Now what will happen, guys? Log n base 2 equal to, this is the power, guys. So power always comes front into log 2 base 2. What is the value of log 2 base 2? Is 1. So now we can say k equal to log n base 2. Guys, we found the k value. What is the k value? K value is how many times subarray dividing. Guys, understand that subarray dividing means how many times that is running. Until if subarray is 1, we will stop the running the array, dividing the array. So that's why we found the K value, K equal to log n base 2. This is time complexity of binary search. Guys, understand how it is the log n. I hope you understand. Please let me know, guys. The most of the guys will confuse it here only. Why it is the log n? Because when I telling you this one, some people may think this is like a root entry. So every time it is going to be double, and again it is going to be double. Some people think like that, but actually what happening here, subarrays may be changing. Subarrays, we are not checking for the how many subarrays. We are checking what are the values, how many, what is the size of subarray, how many times we are going to be run this one until subarray value, subarray size equal to 1. Guys, understand? This is the different thing. Normally, let's suppose we are going to be find a Fibonacci series. How we are doing, like, let's suppose I have given 9. We have to check for like this 8, 7, like that, right? So people may think why it is not 2 power n, time complexity is not 2 power n. Guys, you have now, I think you have clear. Please let me know, guys. Because here we are not checking the number of subarrays in the binary search. We are checking the element, how many elements inside that binary search. Large subarray, how many elements in the large subarray. That's supposed to be 1, then only we will stop. I hope you understand this one. So that's why the time complexity here log n. Please let me know, guys. Okay, guys, fine. I hope you understand. Okay, guys. I have given, let's solve some problem based on the binary search. Yeah, actually, when log 2 base 2 means when there is this called as a actual thing, this called as a base, right? When there is, I don't know what it is called. This supposed to be like, there is a one thing like this. This is the, if suppose a equal to b, that means this value will be 1. I hope you understand. I hope you know about this. It's not cancelling, guys. Here, log of, here base, let's suppose this is the base, this is the thing, and here power. That power is comes to front. Guys, this is the very basic. You will learn in a, I think, 8th or 9th class, this thing. Logarithms, right? The very basic thing. Okay, guys, let's solve the problem. Guys, sometimes they may directly given you array, and they won't tell you, like, in the question you won't find the sorted array, but when you see the question array, you have to find it out. Oh, this is sorted array, so I have to use binary search. Why binary search? In binary search only we are going to be solving an optimized solution. Guys, understand? Okay, guys. Now they have given one array 2, 5, 7, 8, 9, 10. Okay, this is a sorted array. I want to get the index of the given target. Let's suppose I have given a target of 8, 9. How to implement, guys? The same implementation only, right? Just we are calling that. Let's suppose that is the binary search method. We are going to be call that method array with the target. Guys, you know, right, how to call a method from the main method? Main method, you have already implemented. You have already implemented the binary search here. You can see we have already implemented here. So we have to just call this method only. Inside the binary search method, this is only the thing. Guys, you know, right, how to do this one? You have to just call the from here to there. You have to call from the main method. You have to call that binary search function. So how it will be there? Binary search. Let's suppose here int array and target. I'm again implementing, guys. Let's suppose here we need start value. So start equal to 0 and end value equal to array dot length minus 1. This is the basic thing. Then same thing we have to apply the while for this, because this is the 2 pointers. So I'm using the here while loop. Yes, less than or start less than or equal to end. Here we have to do same operation. What we have done here, we have to apply the same operation here. I hope you understand very clear on this one. Right, guys? Okay, guys, we will try to solve other questions based on the binary search. Okay, guys. Sometimes they have given a question like this, guys. 4, 5, 6, 1, 2, 3. Guys, is this sorted or not? Is this array sorted or not? Please let me know. Sorted or not? Please let me know, guys. Is this array sorted or not? It is not sorted, but actually this is array of 1, 2, 3, 4, 5, 6. This is the actual array, but they have given this array. That means what happened, guys? What they have done? They have taken, yes, they have taken some rotation operation here. You can see 1 is here, it comes to here. 2 is here, it comes to here. 3 is here, it comes to here. Guys, understand? Actually, this is a sorted array only. They have done some modification, some rotated. So when you see the question, you have to find it out 2 things. Whether it is a sorted array or rotated sorted array. These are very important, guys. So anyhow you have find it is finally one sorted array. Okay, guys. Now question may be they have given one rotated sorted array and they have given some target value. Let's suppose they have given target value is 6. 6. Oh, let's wait a second, not this one. They have asked you to find the peak element. Peak element. What is mean by peak element means? Peak element means the before element supposed to be small. Before elements supposed to be small. After element also supposed to be small. Guys, here this one is small, this one is small. What will be happen to this one? This is high. Right, guys? Guys, check here. They have given one array, right? In that array, is there any element follow this rule? Small to high, high to small. Is there any array? Sorry, any values follow that one? Check 4 is following. No, because before no element. When comes to here, before element is small, okay. But what about the next element? It's not. So check for the 6th. Before element is small and next element also small. Next element also small. So that's why this is the peak element. peak element. Okay, guys. Now, how many ways we can find this element? We can find that element in the linear search. Linear search. What is the time complexity of the linear search, guys? O of n. I have already told you this one. So this is already you can find it out. This is a sorted array, but rotated sorted array. So we can implement better than this one, right? So that means O of log n only we can implement using the binary tree. Sorry, binary search. Okay, let's implement that one binary search. Guys, understand why I am go for the binary search here? Because this is a sorted array. That's why if you go for the linear search, it will take more time often. But if you do linear search, that is very easy. So we can easily find it out in a minimal time. So optimized solution will be we can find it out using binary search. Binary search. Right, guys? Okay, how we are going to be implement this one? We know already sort value, end value. Right, guys? Now what we have to do? When we have taken two elements like a start and end, those are not adjacent, we go for the while. Okay, guys? Start always to be less than end. This is the base condition. I mean base condition means it is the first condition we have to check. Okay, guys. Here, what is the thing we have to check? We have to first find the mid. How we are going to be find the mid? Start plus end by 2. Guys, why we are finding the mid element? Because in binary search, we are going to be compare the elements with the mid element only. So first thing you have to find, if you find any array, sorted array, so that means must have to do this one binary search. How we are going to be implement by using the mid value. We are going to use the mid value. We are going to be check the compare the element with the mid value. So that's why we have to find the mid value the first thing. First thing we have to do, find the mid element. Okay, guys. Next, what we have to do? So how we know that element is which side? It is already rotated, but we have to find the element. How we are going to do? First, we are going to check the element, mid element, array of mid element with mid plus 1. Let's suppose mid. Why we need to check with the mid plus 1? Guys, tell me one thing. Let's suppose here the one array 4, 5, 6, 7, 8, 1, 2, 3. Okay, guys. If the mid element is 7, guys, understand this one. If mid element is a 7, what I am going to check is the next element. Next element is supposed to be smaller element, right? Smaller element for peak value. Guys, when we found the element, let's suppose we take, if you want to consider that is a peak element, what supposed to do? That previous also small, next also small. Right, guys? That's why we are checking the element. When we find the mid value, we are going to be check the next element. Okay, let's tell me one thing. If the next element, let's suppose mid plus 1 is the next element, that array of mid plus 1 is greater than mid value. What does that mean, guys? Guys, we have an array like this. Let's suppose we have an array like this, 1, 2, 3, and we are moving. We found the mid index here. But actually next index greater than this one, let's suppose 4. That means maybe possibility of the peak element supposed to be its right side only, guys. Because in the right side only we are going to be get the value that and we will get that peak elements. Right, guys? You understand why I have to take here after checking with the next element. We have to change the start value to mid plus 1. Guys, I hope you understand. Please let me know if you didn't understand. I will explain again. Guys, please let me know in the chat box. Okay, fine, will do. Guys, I have given one array here. Let's suppose 4, 5, 6, 7, 8. Let's suppose I have taken as a 1 year. Guys, please tell me what is the peak element in this array? Peak element. What is the peak element here? 8. Yes, 8. That's fine. 8. Okay, guys. Now this is the start value. This is the end value. We are going to be check the mid value. What is the mid value, guys? Mid value will be, this one will be the mid value. Let's suppose we can take here at least. So then at time mid value is 7. Okay. Mid value will be 7 here. Right, guys? 7. You can clearly see this adjacent element after mid element. This is the mid one. This is the mid plus 1. Mid plus 1 is greater than the mid value. Right, guys? Mid index value. What is the mid index, guys? This is the mid value. This is the value. Actually, this is the mid of index. Actually, this is the index mid. This is the index. The mid index here. This is the mid index plus 1. You can clearly check this one. This mid index plus 1 value is greater than. Right? 8 is greater than. So that's why what is the possibility, guys? Is there any possibility that peak element supposed to be there in this side? No. Right, guys? So that value supposed to be right mid right side. Guys, understand this one? Guys, understand this one? Why I have taken? Yes. So that's why. So I have to take the start value as mid plus 1. Because no need to check that elements up to mid. Right, guys? Up to mid. If you check also, no use. Because it's already started. So that's why I have taken the start element as a mid plus 1. Guys, I hope you're clear. Okay, guys. How I have taken here? I'm going to be check here whether this mid index is the smaller than mid plus 1. Mid plus 1. That means start will be the mid plus 1. Guys, this is clear? Wait, I will write here. There's some sync issues, guys. Guys, check this one. We have taken a while loop here. Start less than or equal to n. We have checked the here mid value. We found the mid value here. Mid equal to start plus n by 2. Guys, n by 2. Now, we have already checked the here. How we have checked if using the if condition, array of mid and array of mid plus 1. We have compared this one. In the comparison, what we have got? We have got mid plus element value is higher. Then that peak element is a no chance. Is there any chance to that element supposed to be in left side? No, because the mid plus value is greater than the mid value. Here mid value is more. Here this is the less. So only possibility of to get the peak value is the mid plus 1. So that's why we have taken the start value as mid plus 1. Mid plus 1. Guys, how I have taken mid plus 1 here? Have you understand? Guys, please let me know, guys. Okay, fine. Guys, what is the other possibility? We are going to be check the values here. If not this one, what is the other possibility, guys? Else if array of mid value may be greater than array of mid plus 1. Let's suppose we'll take one values like this. 7, 8, 1, 2, 3, 4, 5. Guys, what is the mid value, guys, here? What is the mid value? This is the start value. This is the end value. The mid value will be, this is the mid value. Right, guys? Guys, have you understand this one, mid value? Yeah. Now check this one. Yeah, it will be 2. It will be 2. It will be 2. Now check the next value. So for this one, is this the next value will be, guys, wait. Guys, let's take this one. Let's suppose here 4, 5, 1, 2, 3, and 4. 4. Okay, guys, this is the start one. This is the end one in this case. What is the mid value, guys? So 0, 1, 2, 3, 4, 5. 0 plus 5 by 2. That means is 2. So this is the mid one. This is the mid one. Wait, guys. We'll take another guy. Guys, now tell me 3, 4, 5, 6. Guys, what is the mid value now? This is the mid value, right? 3 is the mid value. Yes, 3 is the mid value. Now we have to check the what we have taken here. First condition we have checked whether mid element is smaller or not. I mean the next element here, next element is the higher here. In this case, next element we got the here. Next element is higher. Yes, wait a second. Yes, wait a second, guys, please. Guys, wait a second, guys. I'm doing. Okay, guys, wait a second. Okay, guys, check here. 5, 6, 7, 1, 2, 3, 4. Okay. Here first we are going to be check the mid value. Anyway, we have to check with the mid value. Mid value. If the after next value, we have to compare mid with the mid plus 1. If suppose array of mid minus 1 is less than array of mid and array of mid So greater than array of mid plus 1. What does it mean, guys? It means the element, we found one element, that element is bigger than, this is the smaller, this is the smaller, this is the bigger element, right? If you found this case, the any element, mid element, let's suppose this is the mid element. If the mid element is in this case, that means what does it mean? We found the element. We found the peak element. The index is mid. Found index is mid. Right, guys? You understand this one? What if other cases? Else, if let's suppose array of mid is still smaller than the mid plus 1. Mid plus 1. What does it mean? Let's suppose this one, guys. 4, 5, 6, 1, 2, 3. Let's suppose 1, 2, 3. Let's suppose the mid value, we found the mid value here. Let's suppose, let's take this is the mid. Let's take it as a mid. It is not the mid. 1, 2. Let's take this is the other mid element. The next element is greater than the mid element. So that case, what will happen? That element, peak element, is not inside this side. This side, right, guys? It is only the right side of this one, right side of the mid. So that's why we have taken here start value equal to mid plus 1. Right, guys? Why? Because that element is supposed to be this part only. It's not be available in this part. Right, guys? Okay, let's suppose the element is like this. Else if suppose the element 4, 5, 6, 7, 8, 9, 1 and 2. Okay, guys. Now we are going, let's suppose we take it as here 3 as well. Let's suppose we found a mid here. Let's suppose we found the mid here. We are going to be check the before element. Let's suppose we found the mid element is this one. We are going to be check the mid minus 1. If suppose this value is greater than this value, what does it mean? That means it is the possibility of the mid value is left of that element, right? Left of this element. Guys, understand, guys? Guys, please let me know. Yes. So that's why we have to check array of mid. We have to compare with the array of mid minus 1. How is supposed to be mid minus 1 value supposed to be greater than? In this case, what will happen, guys? N equal to mid minus 1. Guys, understand how we have implemented this one? Guys, how? Initially, we are checking, we are getting the one mid value and we are going to be check the mid value with the previous element and next element. If that satisfy this condition, that means that mid value is the peak element. That mid index will be peak element. If not, we are going to be check this condition after mid. Is there any possibility of mid plus 1? If that is true, what will happen, guys? Start will be mid plus 1. And again, we are going to be check this condition. What does it mean? Array of mid less than array of mid minus 1. That means mid minus 1 value is greater value than the array of mid value. Right, guys? this is the higher value here, this is the lower value. In this case, this is the lower value, this is the higher value. So that's why we are taking here end equal to mid minus 1. Guys, understand this one? Yes, applying binary to sort. Guys, and I will tell you that problem also slowly. Guys, I hope you understand this one. Okay, guys. Guys, tomorrow I'm going to be solve more questions on the binary search and we'll start the new topic like a recursion. I'm going to be explain about divide and conquer method, and that is based on the recursion. We are going to be sort the element based on the quick sort. So this is the very important sort, guys. Tomorrow I'm going to be explain recursion and quick sort and based on the some questions. And after that, I'm going to be end these 2 pointers concept, guys. And after that one, I will tell you how to find the element. What does it mean, guys? Bro, every time you are going to be half the element, half the array, right? When we find the element mid means, what does it mean? We have already find the up to mid. We are doing two ways, either mid plus 1 as a start or end as a mid minus 1. Guys, let's take like this. This is the start index, this is the mid index, this is the end index. Right, guys? Every time what we are doing, whether the end will be maybe mid minus 1 or otherwise start will be mid plus 1. Every time we are doing that like this only. So every time that means array is by 2 power n times. By 2 times it's going to be decreasing size. So that's why it is the time complexity is log of n. Log of n. Let's understand this one. Guys, I hope you understand, guys. Guys, you have to check one thing, guys. How the calculation has been happening. How the calculation has been happening. So based on that one only, you are going to be find the time complexity. Here, what is the important thing? Every time we are going to be divide the array until array size supposed to be only 1. Array size is only 1. So that's why the log n, because n by 2 power k equal to 1, because the array size is 1. Initially array size is n. After number of times we are divided, right? By 2, by 2, by 2, by 2. So that is equal to 1. So using this formula, we are going to be find the time complexity. Time complexity. I hope you understand, guys. Okay, guys. Tomorrow I'm going to explain about recursion and quicksort, guys. And based on some problems on binary search. These are the very important things from the like 2-pointer concepts. Okay, guys. After this, I am going to be explaining about sliding window. After that, dynamic programming, some questions from the arrays. These will be enough, guys. If you know these all the things means you may most of the guys know about the basics of the problems. You can easily solve the medium level questions. If you solve what I have given assignments now, if you solve that one, you may get the very strong things. Also, bro, I have already told you every topic, every data structure topic like arrays, strings, and matrix. Every topic may have different concepts like follow the same patterns. That means sliding window, the dynamic programming, and 2 pointers, and there are the different concepts are also there. So same, this is also same, and 2D matrix also same. So I will cover you everything. I will cover. No need to worry. Yeah, we'll give you guys. I know the most of the questions from the substrings related. I will give you. I will train you like that only. No need to worry. Just learn these basics. This is only first week only, right? After like Sunday or Saturday, I will take the long class, like a 3 hour class. That time I will talk about the entire dynamic programming, one dimension dynamic programming that day. So you will easily understand. Okay, guys. And before Saturday, I am going to be complete the strings as well. So in the dynamic programming questions, I will solve in the Saturday, or if I miss the class on Saturday and will Sunday, I will take at least 3 hours, and continuously we are going to be solve at least 10 to 15 questions. So you can easily solve the questions. Okay, guys, fine. Will do. We'll give you other like assignment. I will prepare the question. I'm already preparing some question. I will share it with you. No need to worry. I will give you. Fine, guys. I'm ending the session now.